Welcome to Solar and Storage News with Montague and Weaver. I'm Tim Montague. Check out all of our content at cleanpowerhour.com. It's on audio, it's on video. You can find it anywhere you want. And I'd like to welcome my co-host, John Weaver, the commercial solar guy. Welcome.
Welcome, Tim. Nice to see you again. I hope everything's well. It's a beautiful blue sky outside, like not even a single cloud. The haze from the forest fires of Canada is gone. So I'm going to be checking some solar generation on my O&M stuff today, just to see if the charts look cool, because everything should be maxed out as high as it goes. Midsummer and no clouds, so looking nice.
When you're talking to customers, commercial customers, about the performance of solar projects, what are the weak links in your mind that can lead to underperformance?
Inverters. It's always inverters. That's what it always is. It's always inverters. We don't really have too much that fails. It's always a fuse or a wire loose or some weird grid fluctuation that has a feedback loop into the inverter. Voltage range. It's almost always something funny with an inverter. Sometimes it's the communication, and the inverter is fine. In fact, most of the time it's that. But I did just have a project lose. There was lightning local on the Cape in Massachusetts, and a disconnect and an auxiliary transformer backing up the communication system got zapped. So we're going to have to shut down a system. Well, it's already halfway shut down with the way it's set up, but we're going to have to shut down the whole transformer with the utility because of where the disconnect is relative to everything in line. So every once in a while it's lightning. And in fact, I've actually had two systems within the last, let's say, year now, 9 months. Had one system hit by lightning last September.
Really?
Lost an inverter. Yep. Whole building got zapped, and it just hit that right side of the building, right where our gear was. So we had a melted wire, and it melted the inside of the inverter. And then this one, where that hit a disconnect and an auxiliary transformer that was managing the monitoring system. So still sort of inverter, but technically it's the giant volt of static electricity traveling through the atmosphere.
Here's the tough question. What do you think is the average uptime of a commercial solar project in the United States? I don't know the answer, but I'm asking what you think that is.
97, 98%, maybe 99.
Yeah.
Smaller the project, the lower the uptime. The bigger the project, the higher the uptime.
I'm sure Solar Boy knows the answer, so if you're listening, Solar Boy, tell us.
He always knows.
Perplexity probably knows the answer as well. And all right, well, let's get into the news. You got a story in PV Magazine on deployment of solar in the U.S. and FEOC. I am dying to get to the bottom of FEOC, and many of my colleagues are dying to get to the bottom of FEOC, but the title is U.S. may deploy 53 gigawatts of solar in 2025, 61 gigawatts in 2026, but FEOC looms, by John Weaver in PV Magazine. Yes. What's the story, John?
So Bloomberg NEF, this is their data, their projection for the next 2 years. Mostly the projects in 25 and 26 won't have any FEOC challenges. Foreign entities of concern is what that is. And particularly it's China. And so the analysts at Bloomberg said, if FEOC starts to hit hard, and it's really hard to get projects through FEOC, we could see installations fall in 2027 to just under 60 gigawatts and then collapse in 28. Because by 28, that's when we'll start to see the teeth of FEOC hit projects, because 28 projects probably don't have construction already started right now. And they might not have construction started by the summer of next summer, which is when the FEOC rules really start to chew. I think they do December 31st this year. There's some nuance. But
so FEOC isn't just specific to the ITC?
It is. Well, most solar, it's the ITC and the tech neutral energy credit. So it's the past. So technically, it's not applicable to the ITC. It's actually the inverse. So any projects that were ITC are done. They're not going to have any FEOC concerns. But ITC technically ended end of last year. The only projects that are still in the ITC are those that have already started construction, safe harbored. So they don't care. But for the tech energy neutral, which is related to the tax credit, same thing, just the new name. It is without a doubt FEOC. So if you don't get if you have FEOC violations, you don't get the tax credit. Simple as that. Mm-hmm. You have to be within FEOC rules to get the tax credit. And so this is what Bloomberg is seeing. Now, this is for overall, for wind, solar, and storage in this graph. Mm-hmm. But you can see the hit. This hits wind, this hits storage, it hits wind really hard, and it hits solar. If FEOC is what Bloomberg has said is challenging, impossible to move through. They also give an optimistic one and say, if we figure out FEOC, solar might actually go up in 2027, and we might actually have much better numbers. Like they actually think solar might hit 63 plus in 27. So we could have 250, 220 gigawatts of solar installed in 4 years. It might be a beautiful 4 years of solar, to be honest. 24, 25, 26, 27. So, yeah, that's real interesting.
That's not a very good statistic here from Inverter, right?
Yeah.
It estimates that once the investment tax credit expires, only 30% of planned solar projects will be able to deliver competitive prices and are expected to survive.
But understand that there's expected to be solar projects being built through 2030, surviving underneath the safe harbor of mid-2026, because I think that's how they have to work. Yeah. So, and then you have 4 years, but maybe that'll change. We're still learning, Tim.
If you're a C&I installer, and you're self-developing large C&I, these are megawatt to 5 megawatt projects. The strategy is to safe harbor 5%. Is that what you have to safe harbor of the equipment?
Well, technically, as of today, yes. However, explicitly, Trump said he's going to make it harder. So we don't know what's about to come. But yes, as of right now, as of the signing day of that document, July 2nd, 2025, 5%. As of tomorrow, who the heck knows? But we're waiting on guidance. But yes, so for the big solar contractor, you want to have that safe harbor done by July 3rd or 2nd next summer. But you can also just have your project turn on by the end of 27. But once you start getting bigger, it gets a little harder. So if you have development risk, you got to make sure you safe harbor. If you think you'll get stuff turned on by the end of 27, that should be your goal. So, I'm talking to plenty of people who have these big 4 to 5 year project timelines, and lots of people are safe harboring batteries and panels and transformers, all kinds of gear. I'm listening. There's lots of legal work going on, because then you have to prove it. You have to have the documents. You have to have the warehouse. You got to have the pictures. Or whatever the people are doing. I'm not in that business so much yet myself, but
because you're mostly installing for others.
So mostly installing for others, but also my projects are smaller. So I'm not worried about hitting deadlines as of yet.
We got a megawatt scale project that we're about to talk about here from National Grid, right?
I expect that project to start construction in 26, and or maybe even 25, and it'll be done long before the end of 27.
So this is one of our projects of the week.
Yeah.
What is it we're looking at here? This is a beautiful large flat roof commercial solar.
Oh, yes. So this is a roof in Fall River. It's nearby. We have leased this space from the building owner. It's 999 kW AC. We're pushing the DC up to 1718 because the incentive per kilowatt hour is over 20 cents. And we think we're going to get at least a 40%. We're going to get domestic content on this project. And we're moving through the studies. We've gotten through our first round of interconnection analysis. We've started the impact study, which involved a $29,000 or $32,000 payment. We've been given a high-level analysis of what to expect. There are some questions, though. We have 2 feeder lines that come to this building. One of them has solar on it, one of them doesn't. And we're trying to figure out which feeder line is better. And since we're looking to put a meg, we really got to figure it out. We also have 2 other buildings for the same owner. Both of them are 499 AC, but one's like 675 DC and the other is 800. So we have about 3 megawatts DC. Oh yeah, there goes hit the back button once. So that's our impact study for this. So this is so we already paid for interconnection analysis and engineering. So engineering for us is in-house. Or interconnection is $4,500. Now we got another 29,000 of just grid analysis. Then at the end of that, they'll say, here's what your solar power project will cost to upgrade. And we're moving forward.
Do they use levels, or what? How do they move project from quicker, cheaper to more complicated, more expensive? What is that process?
So step 1 is based on system size. So like if a system was above, I think 300 AC, 300 or above, so 299 or less, you get away with it. But if above 299, then by default, you have to do an impact study. However, in some cases, if you do they do a test. I'm trying to remember the test, but it's a capacity test. And if this capacity test triggers based upon your system size, then you get an impact study, because it depends on the available capacity on your filter, on your feeder line going into the substation transformer. So
they don't have it's like a level system. We in MISO or in PJM, we have levels 2 through 4. Projects usually start with a level 2, which is pretty quick, and then go to level 4, and then it's slower, and then they charge more, and they always have these, okay, now we have 30 more days or 60 more days to review. It's a way for them to slow things down, honestly, and make it more expensive.
Well, the levels for us, we have the different studies that can occur. We do get charged more per project, per kWAC. So that dollar amount increases based on system size.
Yeah.
Hypothetically, we could get money back if the company doesn't use the engineering services that are needed, the 29 grand, but that never happens. But we do expect a 55 business day response for these 3 projects for this portfolio.
And for a megawatt, okay, so ostensibly we're looking at a megawatt of solar, right?
No, 1.8 of solar.
1.8 megawatts of solar.
Yes.
DC.
DC.
Yeah, you really loaded the DC to AC ratio, 1.8 ratio. Wow.
We're New England. We're way north, and we're at 5-10 degrees, so the design allows for it.
It has to do with the incentive as well, right?
Oh, absolutely. You can be less. This is the magic being in the Northeast. You have high electricity prices, so efficiency isn't your number one goal. kWh generation is. We're above 20 cents per kilowatt hour here, Tim. So above 20 cents means we can blow past that 1.3 kWh DC to AC ratio. We can have modules that aren't tip-top perfect output.
And what percent of the facility's load are you offsetting?
This is a 100% being sold straight to the utility in a fixed.
Oh, front of the meter. Okay, yeah.
Yes, sir.
You started by saying you were leasing the roof. So
yes, leasing the roof. Yes.
So it's not community solar though, or it is?
It could be. It could be. That's going to be a decision later on in the process, the development process. To be honest, commercial solar guy is not an expert. Let me rephrase that. Commercial solar guy has not done a single community solar project through the end, having to do the procurement of the community solar buyers and dealing with that headache. This is our first collective batch of projects that we can truly own. And so community solar could be added, and that could add a penny or 2 in revenue per year, but it increases the interest cost because your risk of offtake is slightly higher than if I have a fixed 20-year contract with the power company. So as a low asset company, I might go for the simpler contract because of easier costs.
Yeah. So I have 2 questions. One, is FEOC a concern here at all for you?
I don't think so.
Okay.
We're going to buy domestic content modules. We're going to buy inverters. We really got to pay attention to inverters, but I'm buying SMA inverters, and I'm buying, maybe modules from Haliene. So we'll see. I'm going to work for domestic content. I'm not going to have very much gear coming from China. So I don't think we're going to have those percentages.
And that is explicitly a strategy to avoid FEOC problems, because you're not trying to get ITC, or you are trying to get ITC for the domestic. You're trying to get the domestic content adder.
Absolutely. Okay. Yeah. In fact, 2 of the projects in this portfolio, we're going to get a domestic content, and we're going to get the low income adder. We're going to get 50% ITC.
And to lock that in, all you have to do is safe harbor.
No, you got to buy domestic content stuff. Domestic content is still viable going through into 27. So safe harbors, 2 independent things.
Yeah.
Domestic content's buying the right hardware. And as long as I turn it on before the end of 27, we're cool. Yeah. So we may exit. Yeah.
My second question is, do you have a rule of thumb for estimating the interconnection costs of a project? When you look at, okay, it's 500 kW or it's a megawatt, it's offsetting some big percent, or it's front of the meter. Just like when you walk into these things, there are a lot of surprises that can happen. And, I always encourage my clients to just exclude any upgrades to the grid, for example, that the utility will require. But anyway, how do you approach that?
15 cents a watt is my default number.
Okay.
But real fast, we start making some judgment calls about what we think is going to need to be there. Because we're starting to learn our medium voltage better. And so the medium voltage is going from our gear into the transformer that may be ours or the utilities, and then into the poles. And those poles have things like reclosers and SELs, different types of disconnects and fuses. And so we're a number of poles, and we're starting to get a feel for that. When it comes to big grid upgrades, like running wire and stuff like that, it's real hard to tell that info in Massachusetts. If we have to reconductor or upgrade transformers. So I don't know. I mean, a good rough number might even be $300 to $400 per kWAC nowadays, because in Massachusetts, we're starting to see upgrades, substation upgrade back pay. So the thing we call CIP. Can't remember. It's something infrastructure payments, where it's they upgrade the substation and the state funds it. And then they say, okay, you now have 5 to 10 megawatts of space on the substation, and all of you, when you connect, you have to pay a CIP fee. So far, I've seen them ranging from $317 per kW up to like $379. And so, a megawatt is going to be a $347,000 upgrade fee. And that's 1.8 megawatt. That's like 18 cents. It's a little strong, but that pays for everything to upgrade to the grid and connect and all the fees. So 15 cents, maybe 10 cents in a good time, 20 cents is, I put 15 by default in my spreadsheet when I know grid upgrades are coming. That's my rule of thumb.
I had another comment, but I forgot what it was. Well, that's a great project. Good luck with that. I hope it succeeds. Oh, I did the quick math. Your 15-cent rule would mean like $270,000 for this 1.8 megawatt DC. Do you
feel that's going to be low. I think that's going to be low for this one, because we know we have big grid upgrades coming to some degree. We just don't know what yet.
And did you see those stories about Nexamp?
Yeah.
Where they're covering grid upgrades as a way to expedite development?
They're doing the work. Yes. I wonder if they're going into the substations. I doubt they're allowed to touch. Or I wonder if they're just installing on-site gear, like doing the on-site transformer, maybe a recloser on a pole or stuff like that. I doubt they're going into a substation. I looked at those 3 systems. they were all smaller systems, 1-2 megawatts. So none of them were like, 5 megawatt plus. But yeah, they're doing some work, which was kind of cool.
But I mean, if you're developing a 1 megawatt project, there's no substation work involved. It's just, what is the capacity? I don't know. Yeah, I'm just curious about that. All right, we should move on. I found a story. This is a little dated now. It's a week old, on Peak Energy, a company out of California is shipping a sodium-ion battery. And I'm still learning about sodium-ion, but basically you're relying on sodium instead of lithium, is my basic understanding. And so, they're both super abundant elements. Okay. I think sodium is perhaps a little more easily accessible, even though lithium is super abundant. It's easier to get sodium. The battery looks just like any old battery, right? It's a container. It's got space conditioning, blah, blah, blah. And, what it boils down to, John, is, the cost per kWh and the overall lifespan, which translates into LCOE effectively, right? And in this case, it has passive cooling, which is interesting. Most lithium systems have active cooling, not all, but most. They even have a coolant or water or air. They can be, either or. And I know that CATL is getting into the sodium battery space. So it tells me that there's potential legs. I think today the cost is not competitive with lithium ion. Is that your understanding?
Correct. The stats I've seen for the best price lithium ion is, middle to upper tens, 50 to 70 cents. And the best I've seen for sodium is like buck or 150. Sorry, they're 70 to 80 bucks per kilowatt hour, whereas sodium is 150, 130 per kilowatt hour. Mm-hmm. So right now, sodium in China from CATL is double, maybe less than double, but close to double the price of lithium. And it also doesn't have the same performance characteristics. It's not as dense. And I don't know about the lifetime yet, but maybe it does. Actually, maybe it's better. I mean, I'm looking here. It says cut degradation over 20-year lifetime, that kind of stuff. That's awesome.
Yeah. Yeah. So they make a couple of claims, which is, kind of their secret sauce. You need less active cooling, and the batteries can perform well under a greater variety of extremes. Like lithium ion is very finicky. It doesn't like sub-freezing temperatures at all for charging or discharging. And they don't like to get too hot either. So, you want the battery at like 70 degrees for optimal performance and degradation. And that zone is bigger. It doesn't say exactly what that zone is here. And so, it's the thing that people forget, John, is that when you see stuff being deployed en masse in the world, it is largely about LCOE. It is about the cost of the technology. Ultimately, cost wins. Of course, it has to be durable. It has to be effective. It has to be available. All these things have to line up. But at the end of the day, if something isn't cost competitive, it's not going to happen, right? In the market, period. You can love it all you like, and so it's still early days for, Form Energy, their iron air battery, all these liquid batteries. That's not the expression. What's the expression? Where the electrolyte is a fluid. Flow batteries. Yeah.
Yes.
All these flow batteries, you see them, but they're still dancing around the edges to lithium, right? The vast majority, I think more than 90% of deployed batteries in the US are lithium, right?
I would say 95. I'm looking for actually a thing I've seen, but yes, it's almost all lithium-ion. The volume, I actually have a story about more lithium. Well, we both do. But yeah, it's almost all lithium. I mean, flow's great, but it's just not cost competitive yet. It's going to take time. People believe that the fundamental cost of a salt battery could reach below like 10 to 15 bucks per kilowatt hour, whereas lithium right now is being suggested in the 30 to 35 as the lowest potential price it could reach. And so I think that's what's driving the salt stuff. It's such a common, easy to work with material.
Yes. Lithium is not easy to work with, I don't think.
Little less.
And
great.
Just to wrap this up with a bow, Peak is saying that they've got 9 utility and independent power producer customers doing a shared pilot, and they're going to be deploying a gigawatt hour of product in the near future. And then they're propping up a cell factory, which is going to open in 2026. So, the BBB has really rained on the manufacturing parade big time in clean tech, and there's more factories getting shut down than getting planned and built. So I'm curious to see what battery factories actually come to see the light of day. Announcements are one thing, but it's a whole other thing to actually get the production line rolling.
Yes.
All right, what's our next story?
Well,
another battery storage project.
Yeah, I think this is actually a neat one.
Used EV batteries.
And I just like the terms that this guy used. So this is JB Straubel. He used to work for Tesla. He's the founder, owner of Redwood. And it's just, this paragraph he said, "We're confident this is the lowest cost solution out there.
Yeah.
Not only lower than new lithium-ion, obviously, because it's used, but lower than compressed air, lower than iron air that's formed, and lower than a number of these other ones that carry a little more technology risk." So JB, who knows some stuff, I mean, he's a smart guy. He's got good pedigree. He comes from Tesla. He helped bring them up. He started a company that's now, it's probably a billionaire now. Good job, buddy. Good job, JB.
Yep.
But he sees used EV batteries as the lowest form of long duration energy storage, and that's interesting.
Yeah.
And I think he's right. So I'll just stay there. I don't know how to say like a more refined, cooler thing right now, but the volumes of car batteries that are going to be manufactured and deployed will be 10x. No, 90x. The grid is going to be 5% of the batteries we deploy. So it'll be 20x, sorry, not 90x. So 5% will be grid, 95% will be car. And a third, a half, a quarter, some large percent of these car batteries are going to be just fine when they leave the car. I'm driving. I have my car, my Hyundai Ioniq 5. We're at like 55,000 miles. My battery capacity is about 98%, 96% of its original.
Yeah.
And I fast charge that thing every single time. Like I rarely get a nice slow charge. And it's lasting forever. These Tesla batteries, they're at like 500,000 miles at 90%. The car is going to melt away before the battery goes bad. So if this guy can figure out how to manage these, and somebody on Blue Sky said his biggest fear were failures. How are the failures going to be managed? Are they going to be individual failures? Will they be fires? What are the control systems? That's what his worry was. And I think JB's smart enough to be paying attention to every little component and using the electronics and knowing these systems. And I believe in the concept without a doubt. Reuse. There's repair, reuse, recycle, something like that. And reduce, reuse, recycle. So reduce. We're Americans. We don't know how to reduce, but in this case, we might reuse. And so I'm cool. I'm cool with that. I'm happy.
Yeah. So here's the second story, also in Canary Media, that Julian Spector wrote. Redwood Materials built record grid storage project using old EV batteries. It's about the same thing, the same story, but it talks more about this microgrid. So Redwood is working with a data center developer called Crusoe, just like Robinson Crusoe. Okay, Google them. They are doing a bunch of massive data centers in Texas, in Wyoming. And some of these data centers are slotted to become 10 gigawatt data centers, but they build a 1 megawatt data center with Redwood that is off grid. It has 63 megawatt hours of used EV batteries. Okay, you see them here covered with plastic to keep the dust off them. This is the high desert near Lake Tahoe. And a 12 megawatt solar farm. And the batteries apparently can give this data center like 5.5 hours of pure off-grid operation. Now, I don't know if they have another backup data source, energy source, or if it's all battery and solar. That question is TBD. But this feels, John, like in a way, a new era is starting, and that is the era of off-grid data centers. And it's important because, well, our data center usage is exploding because society has realized that we can make money with AI and make our businesses more efficient. And so there's this rush into AI, and it's all about infrastructure. You need data centers that are full of these NVIDIA GPUs, right? That is the bleeding edge, is the NVIDIA GPU data center, and they're energy hogs. But if you build them off grid, you can actually get them online faster with solar batteries, and they're including gas generators oftentimes on site. So it's a both and. And I don't know that we're going to reduce our carbon footprint by doing this because there's so many data centers that are getting built, but it is going to be a boon for solar and battery professionals. So just if you're listening to this, just know that microgrids are the future, and they're both and, right? You're connected to the grid one moment, and then you're disconnected in your microgrid at the next moment, or they're completely off grid. But the hybrid is quite common where they're grid tied some of the time, and then they're microgridded some of the time. And this is a very unique value stack that you can do at scale now, right? At hundreds of megawatts and soon gigawatts. And I just think it's very exciting.
I'm hesitant to jump on the off-grid train.
Yeah.
What may occur though is that they may, in order to get their machines up and running, because they just want to get it built and get going, is go off-grid first and say, okay, we got 100 megawatt hour battery, got 100 megawatt of solar. We can run our system at 80% capacity, and we'll just wait for the grid to come to us. And it'll get there in a year or 5, and then we'll add a new gas generator when we finally get one delivered to us. But maybe. I mean, we'll see. It's so big to do these data centers. It's hard for me to believe, but who knows?
Yeah. Yeah. One of the projects, I think it was in Wyoming, the data center was going to consume more electricity than the entire state otherwise.
That's
and it's
great.
And I think that's a 1 gigawatt phase one, and that's scaling up to 10 gigawatts of load. So they measure data centers in gigawatts generally. I mean, this is a smaller one in the story about Redwood. But do you want to wrap up with a story about solar panel technology, or should we call it a day?
Should we do solar panel tech or China exporting? Let's do the ICO module, and then we'll do, because that one I think is pretty cool. It's got a good little headline, and I want to talk about ICO a little, just a tiny bit. One day I want to buy a module from them. I've never actually seen one of their products for sale. I expect them to be expensive.
ICO unveils upgraded Infinite series featuring first ever 500 watt solar module under 2 meters squared. So if you bought a solar module, a 500 watt module from, Canadian Solar, how many meters squared is that?
Well, it's probably 2.4. It's probably a commercial sized panel from 2 years ago.
Okay.
Because nowadays the standard commercial panel is probably 570, 600 from a Canadian solar type.
Yeah.
This is a residential panel.
Okay.
That's what's cool about this, or a small business.
Yeah, you
panel.
don't see a lot of 500 watt residential panels.
I don't think you see any. I think this might be the first. I think the highest I've seen is 470-ish. And when I talk residential is a panel that's below 50 pounds so that one person can move it on a small, inconvenient place. And that's kind of the OSHA regulation, is under 50 pounds. So a 50-pound module, and the efficiency is high. The efficiency is over 25%. So that's actually the next one I'd love to just show for a quick second. Is that there's a series of modules that are now above 800 watts, large commercial, but a whole bunch of modules that are above 25% efficiency. I've never seen one. I've never touched one, never smelled one in real life. So I think they're real, but there's 17 modules, and this is one of them. And this ICO brand, they've made a decision that they're not going to sell for cheap. They're going to sell for value. They're taking the SunPower road from way back in the day when SunPower modules were like $1 a watt and everyone else was 60 cents. And that's part of the reason SunPower went out of business. But
yeah, so this table's on screen now. 5 companies surpassed 800 watt Solar B PV module power ranking July 2025.
How cool is that?
840
some of them are
watts.
perovskite.
840 watts is the number one. That's from Trina. And then it goes down to 745. The low end is 745. And it gives the dimensions. So we could do the area calculation, but
yeah, so these were all modules in the 22, 23, except for those tandem modules. Like the first 2 are tandem. The ICO one isn't a tandem. The 5th one is a perovskite, but the top 2 are very high efficiency modules. We're talking like 26, 27%, because those are next gen. They're not really available, but they'll be here soon. And
what
those,
what is the ICO's ABC technology, though? I've never heard of that.
Back contact.
Oh,
so this is it's just back contact.
It's
but
like
here's a cool
SunPower,
thing.
right?
Absolutely. It's SunPower. It's what LonG is moving toward in a lot of their stuff. So ultra high efficiency, and the backside, the interconnects are made out of copper instead of silver. So they save good money. That's one of the benefits of this product. So it's a premium product that is cost effective in some aspects of it, which is great. So I want to buy an ICO module at some point. I went to one of their parties when I was in Munich, and the room was giant. They had one of these cool beer halls, and it was awesome. Just good social event to talk to people. Met some distributors from Italy, and I thought that was pretty neat.
ICO sounds Japanese. Is it Japanese?
I'm pretty certain it's Chinese.
Chinese. Okay.
Yes. I mean, I don't know, but
well done on them for making a Chinese name that sounds like Japanese.
Well done for making a 25% module. That's what I like. So,
what do you mean a 25% module?
25% efficiency.
Oh, 25% efficiency. Yeah, good on them. That's very cool.
Well, check out the very next link. We do this one for the last one. Super fast. Right below it, Solar B Global. That's 17 products that are above 25% efficiency. And ICO's on that list a couple times. Okay. So this is a list of hardware that'd be cool to install one day. Just to have, efficiency. I like efficiency.
Okay. 17 products from 14 companies achieve over 25% efficiency. Solar B PV module efficiency ranking, July 2025. Are these Solar B dudes for real?
Yeah, absolutely. It's a good site. They don't do depth research, but they find out good data. Some of their articles are a little longer. But look at the top 6, 7, 8 modules. 26, 30%. See the top one from Trina? 30%, Tim. Holy something, Tim. 30%. It's coming.
But that's tandem.
That's a tandem perovskite. Yes, sir. Yes, sir. Now you can see, is ICO even on this list? Yeah, ICO Solar, number 14. That's that 25%.
Yeah.
This is cool, man. A lot of these modules aren't available. HBC from LonG, that's one of the most efficient, normal. That's module number 8. That's the most efficient normal module in the world. Is that it's a back contact HIBC. I don't know what their HI stands for, but it's just cool looking at. This is the coolest list. This is the race car list, Tim.
Yeah, for sure. And you see some of the big players here, though. The JA Solars, Trina Solar, Jinko Solar, Longi, and Trina.
GCL, Tongwei.
GCL is here?
Yeah, GCL's number 2.
Oh, yeah, GCL there. Yeah. Okay. I'm less familiar with Tongwei, but
they're big. They started at the other end and they've moved upstream. So they started that downstream, pardon. They started as one of the largest makers of polysilicon or cells or wafers, one of those 3. And now they own the whole supply chain from poly through wafers, cells, modules, probably project development as well, because big name. Lots going on, Tim.
Well, you're always good for a little PV technology update, John. So I appreciate that.
Thought about it particularly. I didn't have one of the prior weeks. We didn't have much PV update. I had to get my perovskite fix. That was necessary.
Yeah. So we're back on August 22nd, if all is well, and we're doing this every other week at noon Central, 1 p.m. Eastern. Check us out on cleanpowerhour.com and YouTube. John, how can our listeners find you?
Commercialsolarguy.com. That's the best way to get us. Got a website, got a contact form. You can call us, 508-4999-SUN. That's a cool way. Now, but Tim, are you going to RE Plus in Vegas?
Going to Vegas, baby. Heck yeah.
All right. Do we want to do a show from Vegas?
We can totally do it.
Time?
We can totally do it. We may be in the press. We may be in the press room, but we can do a show from Vegas. I'm all about that.
I got my press pass. I hope you do too. So,
I haven't got my press pass yet. I need to get on that.
Get on it. Tim Morris at RE Plus. He's the guy.
Yep, for sure. All right. Well, we'll see you in Vegas. But we're going to be back here before that. So we'll be back the week before Vegas or 2 weeks before Vegas. And with that, I'll say, let's grow solar and storage. I'm Tim Montague. Have a great day.